Okay, welcome to Unit 3, Lesson 1. So this lesson is about functions, and the goals are to be able to demonstrate an understanding of functions as mathematical models and function notation, and to find the domain and range of a graph. So in order to accomplish this, first we should figure out what a function actually is. So in mathematics, a relation is any set of points that connects two variables. So any relationship between an independent and a dependent variable. So these are pretty much any of the relationships we look at in mathematics. However, there's a special type of relation known as a function. And what makes a function special is that there is only one y value or dependent variable value for each x value or independent variable value. So no two points can have the same x coordinate, or in other words, every x value has only one y value. So there are a couple of ways this can be represented. One of the ways is in a table of values or a mapping diagram. So here are two relationships between days of the month and the minimum daily temperature. So we'll look first at relation A. So in relation A, we see that the x value of 0 corresponds with the y value of 0. However, we also see that the x value of 2 actually corresponds to two different y values. And this manifests in our mapping diagram because the x value of 2 maps across to two different y values. So it actually has two arrows coming from a single x value. And this happens again for the x value of 4. It maps to two different y values as well. So this is what we call a one-to-many relationship. One x value maps to many y values, and this is not a function. It doesn't meet that definition that we established earlier where each x value has only one y value. So this would not be a function. If we look at the next one, relation B, we see that each x value maps to only one y value. And this is really easy to see visually in the mapping diagram because each x value has only one arrow coming from it and going to a single y value on the other side. So this is what we call a one-to-one relationship, and this is a function. So if you're going to classify something as a function, it has to be a one-to-one relationship, not a one-to-many relationship. So this is how you can pick it out in a table of values, but you can also identify these features from a graph. So if we look at a few graphs here, the first one is a parabola. So we can look visually at the graph, or we can look at a table of values created from the graph. So if we just quickly make our table of values here, it looks like this. So this is an interesting one because we have two different x values that map to the same y value. That's actually okay. It's okay if two different x's have the same y, so this is still a function because each x still only has one y. It's okay if they're the same one. Each individual x has only one y. And visually on the graph, we can tell this by something called the vertical line test. So if we draw a vertical line anywhere through the graph, it only crosses the graph once. And this is interesting because a vertical line basically represents an x value. So if the vertical line crosses only once, we know that means that that x value, where the vertical line is, maps to or corresponds with only one single y value. So that's a handy visual trick to use with a graph to see whether or not it's a function. So if we look at the next example, the square root of x, we can complete our table of values pretty quickly. And again, we see that each x corresponds to only one y. So this is also a function, and again, it would easily pass our vertical line test no matter where we draw that vertical line. Now, when we look at the third example, when we use the graph to complete the table, when x is negative 4, y is 0. When x is positive 4, y is 0. However, So this isn't a problem yet because these two x's each have one y. But when we look at when x is 0, y could be either 4 or negative 4, or both of those at the same time. So this is a situation where the vertical line test fails. So a vertical line crosses the graph twice, and that actually happens at many other places on the graph. So this is a situation where we have one x that corresponds to more than one y, so this is not a function. So now that you can identify functions or distinguish functions from those that aren't functions, the next concept to look at is domain and range. So when we're considering domain and range, the domain is the set of all the values for the independent variable. This is often just the set of real numbers, although not always, so it's really important to be mindful and look at the graph. The range is the set of all values for the dependent variable. So when we're communicating domain and range, we use set notation, which involves the curly brackets. So if we look at some graphs below, it's really important to have a graph to look at when you're finding domain and range. So if you're not given a graph, I would strongly recommend that you use your GDC to graph the equation so you have something visual to look at to figure out the domain and range. So the first one is a straight line, and when the ends of the function or the ends of the graph extend right through to the borders of the plot, that means if the plot were big enough, the function or the graph would carry on forever and ever. So we have to assume that this line carries on because it goes right through to the edges of the plot. So when we think about that, the x values that would make up this line would theoretically be all of them. If the plot were big enough to extend infinitely in all directions, we would eventually hit every single x value. So the domain is just that x is an element of the real numbers. Any real number, it will fall on that line at some point. Similarly, the same thing would happen for the y values. If this plot extended infinitely up and down, the line would carry on forever and we'd eventually hit every real number for the y's. So for the range, y is an element of the real numbers. Things get different when we have something that's curved. So if we look at this first parabola here, it has a minimum at the origin, 0, 0. So when we think about the domain, the parabola will get wider and wider. So in an infinitely large grid, we would eventually widen to hit every x value. So the domain is still x is an element of the real numbers. However, when we consider the range, the y values exist only until y equals 0, and then they turn around and start increasing again. So we will never see on this graph a y value less than 0. So for the range, y is a real number, but y is greater than or equal to 0. So there's a restriction there that we have to be mindful of. So for the next graph, we see it starts at the origin. So there's actually going to be restrictions on both the domain and the range. So when we look at the x values, our lowest x value is 0, and we increase and carry on from there. So x is any real number, but x has to be greater than or equal to 0. And we see the same for the y's. Start at 0, and eventually, as this increases and gets higher and higher, we would see every y value as long as those y values are greater than or equal to 0. And for the last parabola, which is inverted, we see a maximum at 3. So our domain, similar to the last parabola, the parabola would widen infinitely, so we'd get a domain of all real numbers. However, our range is restricted to y values less than or equal to 3. So it's just really helpful to have a graph to look at when you're considering domain and range. And make sure your notation is accurate as well. So the last part of this video is looking at graphs. So on IB assessments, there are two different command terms when it comes to graphs. One is drawing a graph, and the other is sketching a graph. So when we're considering drawing, we have some characteristics for that listed here. So when you're drawing a graph, you're going to build a table of values, choose some both negative and positive values of x, and plot those coordinates accurately on a grid, join the points with a straight line or smooth curve. So if we look at this function here, y equals negative x plus 1, we can quite quickly produce our table of values. So if x is negative 3, we have negative negative 3, which is positive 3 plus 1, so 4. When x is negative 1, y will be 2, this will be 1, this will be 0, and when x is 3, this will be negative 2. So if we create some grid lines here, then we have our vertical axis, which is the y, our horizontal axis, which is the x, and then we can plot our points. So we have negative 3 on the x, so 1, 2, 3, 1, 2, 3, 4. We have negative 1, 2, 0, 1, 1, 0, and 3, negative 2. And then what we would do is we would connect these points with a line, and that would be our graph. And then we can look at the values of the x and y intercepts. So the x-intercept is 1, 0, and the y-intercept is 0, 1. So we can label those points on the graph as well. So when you're drawing, you need to be really precise about the points and the labels and the information. The alternative to drawing is sketching. When you're sketching, you really just need the general shape and direction and areas of that relationship. So 2x minus 1, I know I'm going to have a y-intercept around negative 1 or at negative 1, and I know my slope is going to be an increasing slope. So my graph might look something like this. So that's a sketch. General direction, slope, and y-intercept are there, but you don't need any extreme precision other than labeling things like axis intercepts. So that's the distinction between drawing and sketching. Draw is really, really accurate. Sketch can be quite rough, but needs to match the general properties of the graph as you might see it on your graphing calculator. So hopefully you're now comfortable with functions, domain and range, and representing graphs.